Hello everyone, welcome back to the series of Matplotlib PyPlot. So far we have already learned about plotting in Python using PyPlot module. In this video we are going to learn about histogram, frequency distribution and box plots. Let's get started with histogram. A histogram provides a visual interpretation of numerical data by showing the numbers of data points that fall within a specific range of values, which are also known as beans. It is similar to what we have already seen in vertical bar graph. However, a histogram, unlike a bar graph, shows no gaps in between. So we can say that histograms are a great way to represent continuous data such as weight, height, etc. But whenever we have categorized data, in that case it is always recommended to use bar charts. So in Python we can create histogram using the following syntax. The hist function is used to create the histogram, and these are the parameters which are accepted by the hist function. First we need to pass our dataset for which we are going to create our histogram. Then there is a parameter called beans. By default the value is set to none, and we have cumulative. By default it is set to false, and the next parameter that we have is his type, and by default it is set to bar, and the align is set to mid, that is middle, and the orientation is set to vertical. In this video we are going to learn about this function hist, and also we are going to discuss about all those parameters. So x is basically the array or the sequence of array for which the histogram has to be plotted or is to be generated. The bean specifies the range of values, that is how many ranges are to be generated for that particular histogram. The next parameter that we have is cumulative. So cumulative accepts two kind of values, that is either true or false, which is a boolean type. So cumulative, if set to true, then a histogram is computed with each beans given the count in the bean plus the bean of smaller values. We will also try to understand this from practical perspective. The next parameter that we have is his type. So this parameter basically helps us to determine the type of histogram that we want to generate. So these are the following types of histogram which are supported: bar, bar stacked, step or step fill. The next parameter or the last parameter that we have is the orientation. With the help of the orientation parameter we can orient our histogram in horizontal and vertical format. So these are the basic terminologies from theoretical perspective. Now let us try to understand what exactly histogram is and what are those parameters from practical perspective. As I have already said, histogram is used for continuous data. In this column B you can see that I have stored the marks of few students in an unsorted manner. So this is a list of marks of students, and in this column G you can see that the same marks are being stored in a sorted manner. Now let's see if I divide all those marks in some sort of ranges. Let's say the first range is 10 to 15, and the second range is 15 to 20, and the third range is 20 to 25, and the fourth range is 25 to 30. Now if I want to divide all those marks in those particular ranges, then we can make out that in the range of 10 to 15 we have 2 marks, that is 10 and 13, and in the range of 15 to 20 we have 2 marks once again, that is 15 and 19, and in the range of 20 to 25 we have total 5 marks, and in the range of 25 to 30 we have 3 marks. So these are basically the class interval or the ranges, and these are basically the frequencies. From this table we can make out that here we have divided these entire marks into 4 ranges. So these are basically the beans. Here, so from this table we can see that number of beans in this particular table is 4. I hope the basic concept related to histogram is clear. So histogram is all about continuous data. Now let us try to understand the histogram from a Python program. So here I have a list named X, and I've already stored those marks in this particular list, that is X, and now from this I want to generate a histogram. So in order to generate a histogram I will use the alias name, that is plt.hist function, and here I will be passing the X list. After that I will call the show function. Now let us try to generate the graph and see what is the output before passing any more parameters. From this dataset we can easily make out that the entire dataset is being divided into some sort of range that is being generated by this system. So if we want that the dataset should be divided in this particular range and should have such kind of frequencies, so for that we have to use the beans parameter. Now let us try to use the beans parameter and set the value of beans to be as 4, so that we can have these 4 ranges. So let us try to use the beans parameter. Here I want to divide the entire dataset into 4 ranges. So here I will pass the beans to be as 4. Now let us try to execute the code. From this we can see that we got our graph, but from this we are not able to differentiate among the bars. So in order to differentiate among the bars, what we have to do is we have to pass one more parameter, that is edge color. In that way we will have some sort of different color of edges so that we can easily recognize the bars, or we can easily recognize the edges of the bars. Now let us try to pass our next parameter, that is edge color. As of now I want to keep the edge color as black. Now let us execute the code and see the output. So as soon as the code gets executed, we can see there is a drastic change in the output. I hope the concept of beans and x is clear. Now let us try to move ahead to the next parameters. So the next parameter that we have is cumulative. By default the cumulative is set to false. So it accepts two kind of values, that is either false or true. So let us try to change the value of cumulative to as true and see what is the output. Let us try to execute this code. From this output we can see that our graph got drastically changed. All those values are now being present in a sorted manner, and we have our cumulative frequencies displayed. So whenever we pass the parameter cumulative to as true, what it does, it sorts the data and it presents a chart with cumulative frequency. Now let us try to move ahead to the next parameter, that is hist type. These are the following types of histogram that are supported by the hist function. By default the hist type is set to bar. Let us try to explore the bar stacked, stepped and step filled. In order to get the histogram type, we will use the hist type. As of now, let's say I want a step graph. So I will pass the step parameter. Now let us try to execute the code. From this code we can see that we got a step graph. So this is what a step graph looks like. Now let us try to pass a step filled. So as soon as I execute this code, you can see this is what a step filled looks like. So this was all about bar, step and step filled. Now let us try to explore the bar stacked. So in order to have the bar stacked, let us try to create one more data set. In order to generate the histogram as bar set, we will require one more data set. Let's call this data set as B, because it will carry the marks of students from section B. Let's rename X to A. So from this to list we can see that these are the marks of students from section A and these are the marks of students from section B. Now let us try to pass both the data set. Now in the parameter hist type, let us try to pass the bars stacked and generate the histogram. So from this output we can see we got a bar stacked histogram. And the last parameter that is left out is orientation. So orientation will help us to determine the layout of the graph. So we can generate the bar graph in horizontal format or in vertical format. By default the orientation is always vertical. Now let us try to generate the graph in horizontal format. For that we have to pass the orientation parameter and we have to set it as horizontal. Now let us try to execute this code. Since we have passed two dataset, that's why it is showing two graphs. So if we remove one dataset, then it will show a single bar. So this is how a histogram looks like in a horizontal format. So this was all about histogram. I hope the concept of histogram using PyPlot is clear. Now let us try to generate frequency polygon. So before getting started with frequency polygon, one thing we must always note that in order to generate frequency polygon, we don't have any specific function in Python through which we can generate frequency polygon. But there are a few steps following which we can generate a frequency polygon. So in order to generate a frequency polygon in Python, we need to follow the following steps. That is, first we need to generate the histogram for the data. After that, we need to mark the single point at the midpoint of the interval. That is, we need to mark the middle point of the particular interval. After that, we need to draw the straight line and connect the adjacent points. Next, we should connect the first data point to the midpoint of previous interval on x-axis. And lastly, we should connect the last data point of the midpoint of the following interval on x-axis. So these are the points which we have to follow in order to generate the frequency polygon. So let us try to understand these points from practical perspective. Here you can see a frequency polygon. So in frequency polygon, what we have to do is we have to get the midpoint of all the intervals. So let's say 140 to 150 is one interval. So here the midpoint is 145. So we have to get the midpoint of this particular interval. Here in this particular range from 150 to 160, the midpoint is 155. So this is the midpoint of this particular range. And in this particular range, we can see that from 160 to 170, the midpoint is 165. So in order to generate a frequency polygon, we have to get the midpoints of a particular interval. After that, what we have to do is we have to connect those midpoints through a line. So this way we can generate a frequency polygon in Python. Now let us try to perform an example to understand better. So here we can see that I have a data set called marks. It is a list type, so it contains the marks of all the students. Now if I need to generate the histogram of this marks, what I need to do is I need to call the alias name, and I will call the hist function, and what I will do is I will pass this marks, and I will set the bins to be as 4 and edge color to be as black. Now let us execute this code. So as soon as the graph generates, we can see this is the first range, that is 10 to 14 point something, and the midpoint is 12.5, and from 14 point something to 19 point something, the midpoint is 17.5, and in this range the midpoint is 22.5. So this is the graph that got generated. In this first range we can see the midpoint is 12.5, and the second range we can see the midpoint is 17.5, and in the third range we can see the midpoint is 22.5, and in the fourth range the midpoint is 27.5. So in order to generate a frequency polygon, what we have to do is we have to connect all those midpoints through a line. So in order to connect all those midpoints through a line, what we have to do is we have to fetch all those midpoints from this particular graph. So in order to fetch all those midpoints from this particular graph, we are going to perform some few steps. Now before fetching those midpoints, let us try to fetch all those values of x-axis and y-axis in a particular array. So if I assign this particular function to an object, let's say array, so here in this array object what we will have is we will have the array of x-axis and the array of y-axis. Let us print this array in order to understand it. So in this execution you can see I have the array of x-axis as well as the y-axis. So this is the array of x-axis and this is the array of y-axis. That is all those values that are present in x-axis and all those values that are present in y-axis. Now let's see, if I need to get the values of x-axis, what I have to do is I have to pass the value to be as 1, since it is in index 1. Now let us execute this code. So as soon as I execute this code, we can see that we got the values of x-axis. As of now, we will store this value of x-axis in a variable named x. So here we can see that we got the precise values 10, 14.75, 19.5, 24.5 and 29. Now in order to generate the frequency polygon, we are going to use the concept of slicing. So what we are going to do is we are going to slice the array x, and we are going to slice it 2 times so that we can create 2 different arrays. Let us try to create our first array. So before creating our first array, let us try to execute this code so that we can understand it better. So in the first slice, what we are going to do is we are going to store the elements from index 1 to the last element, and in the second slice what we are going to do is we are going to store the values from the first element to the second last element. I am going to repeat it once again. In the first slice what we are going to do is we are going to store values from the second element to the last element, and in the second slice what we are going to do is we are going to store the values from the first element to the second last element. This we are going to achieve by the method of slicing. So these are the 2 slices which I have created. Now let us try to execute this code. This is our original array and this is the sliced array. So in the first slice we are getting the values from the second element to the last element, and the next slice we are getting the values from the first element to the second last element. So in order to get the mid values, what we are going to do is we are going to perform arithmetical operation on this 2 array. That is, we are going to add the value of the first elements, the second element, the third elements and the fourth element, and we are going to divide the output with 2. In that way we will be achieving the mid values of all those. So logically, if you think, this 2 values becomes one range, this 2 values becomes the other range, and this 2 values becomes the third range, and this 2 values becomes the fourth range. So here we will create an object named mid values. So here we will add this sliced array. Either you can divide it with 2 or you can directly multiply it with 0.5. In my case I will divide it with 2. Now let us try to execute this code. So as soon as I execute this code, you can see that I get the mid values of the ranges. So now we are good to go. Now we can generate the line graph using this midpoints. All these parts are not needed as of now. Now let us try to get the y-axis values as well. So in index 0 it stores the value of y-axis, and in index 1 it stores the value of x-axis. Now let us try to generate the line graph. Here we'll pass both the values. In x-axis we are going to pass the mid values, and for y-axis we are going to pass the value of object y. Now let us try to generate the graph. So as soon as I generate the graph, we can see that we got our line graph, but this line graph is not connected with the base of x-axis. So in order to make the line graph connected with the base of x-axis, we need two more values so that the line graph starts from the base. That is, we have to add one value in the index 0 and we have to append one value in the last index. So in order to insert the value at index 0, I will use the np_alias name and I will use the insert function. Here I will pass the array name. In my case, the array name is mid values. I will pass the position, that is index 0, and I will pass the value, let's say -1. And in order to insert the value at the end, what I will do is I will use the append function, and p.append. I will use the array name and I will directly pass the value, let's say 34. So in order to create a balance between the x-axis and y-axis, I will also insert two values in y-axis. Let us try to call the plot function and pass the values. Now let's execute this code. Okay, so as soon as I execute this code, we can see that we don't get our desired output because we have not stored them in an object. So let's store them in an object. Now let us try to execute this code. So as soon as I execute this code, we can see that the first line gets connected with 0, but the last line doesn't get connected with 0 because we have increased the value. So for that, what we have to do is we have to again pass it to 0. Now let us try to execute this code. So as soon as I execute this code, we can see that we get our desired frequency polygon. I hope the concept related to frequency polygon is clear. So this way we have generated frequency polygon using the concept of slicing. Now let us try to move ahead to the next section, that is the box plot. So this is the basic anatomy of box plot. So this region is basically known as the minimum region of the box plot. This is known as the lower quartile. This line is known as whisker. This is known as median. And this is basically the box or the box plot. This is the upper quartile. This is the whisker once again, and this is the maximum region. And the difference between lower quartile and the upper quartile is basically the interquartile range, which is also known as IQR. So this is the basic anatomy of box plot. I hope the basic anatomy of box plot is clear. So we have minimum value, we have quartile values, we have upper quartile values, we have median values, and we have maximum values. Now let us try to go through the basic syntax of box plot in Python. So this is the basic syntax to generate the box plot. We have to use the boxplot function and we have to pass the x-axis value, and these are the basic parameters which are supported by the boxplot. The first parameter which it accepts is basically the x-axis, and the next parameter is basically the notch. By default, the value of notch is set to be as none. We will try to explore each and every parameter practically. The next parameter that we have is vert. Vert is basically vertical. It again accepts a boolean value, that is true or false. By default it is none. It's basically the mean line of the box plot. It also accepts boolean value. By default it is set to none. Show means, if we want to show the mean value, then we can set it to as true. By default it is set to none. It also accepts boolean value. And show box also accepts boolean value, and by default it is set to none. Now let us try to understand box plot from practical perspective. So in order to generate a box plot for this dataset, what I will do is I will use the alias name and I will call the boxplot function, and I will pass this marks as an x-axis parameter as of now, and let us try to generate this graph. So as soon as I execute this code, I get my graph generated, and this is the default box plot which I get. Now let's say if I need to have a notch, or if I need to remove this parallel lines, I need to have a notch. For that I have to pass one parameter, that is notch, and I need to set the value to be as true. Now let us pass the next parameter, that is notch. Let's execute this code. So as soon as I execute this code, we can see there is a drastic change in the parallel lines. We get our parallel lines converted with a notch. Now let us try to explore the next parameter. Let's see if I need to show mean value of this particular box plot. For that, what I need to do is I need to use the parameter show means, and I need to set it as true. Now let us execute this code. So as soon as I execute this code, in this graph we can see that we get our mean value. So this green colored triangle is basically the mean value. Now let's see if I don't need to have this lines. In that case, I can also set the value of show boxes to be as false. In that case, I won't be getting the boxes. Let's execute this code. So as soon as I execute this code, we can see that we don't get our boxes. Now let's say instead of this triangle, if I need to have a mean line, then we can use a parameter called mean line and we can set the value to be as true. Now let us explore the parameter. Let's execute the code. So as soon as I execute this code, we can see the output that our triangle got replaced with a line. Now if I need to generate our graph in a horizontal manner, that can also be done using the VRT parameter. For that, I need to pass the VRT parameter and I need to set the value of VRT parameter as false. This way we will be able to generate the box plot in horizontal manner. Now let us try to execute this code and understand it better. So as soon as I execute this code, the box plot got generated in a horizontal manner. So these are some of the ways by which we can generate our graph in Python using PyPlot. So this was the last video of Matplotlib PyPlot series. I hope the basic functionality of Matplotlib PyPlot is clear. Now we will try to learn about the upcoming modules of Python in my next video.